Assalamu alaikum everyone, and our today's topic is the electrical energy and the Joule's law. Right. So, by definition, the energy lost by a charged particle Q in order to do work when being applied by some kind of potential difference is called electrical energy. So, जब भी हम किसी charged particle पर potential difference apply करते हैं, then it will lose some of its energy in order to do some kind of work. Okay. So the energy lost by that charged particle whenever we apply some kind of potential difference to it, in order for it to do work, it has to just lose energy. And that loss, the energy lost is called the electrical energy. आप बिल्कुल भी electrical energy से confuse नहीं होना है. So the electrical energy and the electrical potential energy, okay, are different terms. Electrical energy is simply the energy lost by the particle in order to do work, right? But electric potential energy is something different. Electric potential difference. Electric potential energy is basically the energy of a particle due to its position with respect to the other particles, right? So these are two different terms. Electric potential energy is just similar to the gravitational potential energy, right? But electrical energy is the energy by the energy lost by a particle in order to do work, right? So these are two different terms, and you have to just keep it in your mind that you cannot mix up the definitions of electric energy and electric potential energy, right? So mathematically, the potential applied across the charged particle is equal to the work done by the charged particle or the energy lost by the charged particle. So work done by the charged particle can be written as W by Q, and energy lost by the charged particle can be written as E by Q. Now rearranging this equation, we get V equals to E by Q. We need the equation for E over here, okay? So यहाँ पर हम just क्या करेंगे, E को एक साइड पर छोड़ेंगे, equals to V के साथ Q को multiply कर देंगे, so it would become E equals to QV. This is the first equation, and आगे चल के हम लोग इसी equation को transform करते रहेंगे. Now I equals to Q by T. Now we need some kind of equation to transform these things, okay? सबसे पहले Q की कोई वैल्यू ढूंढते हैं. सबसे इजी वैल्यू Q की है I equals to Q by T से निकल सकती है. So we are gonna evaluate the value of Q from I equals to Q by T. Q को एक साइड पे रखेंगे, T को दूसरी साइड पर मल्टीप्लाई कर देंगे. It would become Q equals to IT. इक्वेशन नंबर 1 में इक्वेशन नंबर 2 को पुट करेंगे so that हमें Q की वैल्यू मिल जाएगी वहाँ पर. E equals to IT multiplied by V. This is the first equation of electrical energy. For the second equation, we are going to use the Ohm's law. V equals to IR. Okay, this time we are going to use the value of V over here. So V equals to IR को directly हम लोग equation A में put कर देंगे, and we would get E equals to IT into IR. IR is the value of V. So here हम लोग just I and I को multiply कर देंगे, I square हो जाएगा, R वैसे ही रहेगा, and T भी वैसे ही रहेगा. This is the second equation of electrical energy. Now for third equation, हम ऐसा भी कर सकते हैं कि किसी न्यूमेरिकल प्रॉब्लम में अगर हमें I given ना हो, हमें V given हो, then what would we do? We are again going to use the Ohm's law over here. I की वैल्यू निकालेंगे Ohm's law से, I equals to V by R, so I square would be equal to V square by R square. Here square and R would cancel each other, and we are left with E equals to V square divided by, यहाँ पर एक रह जाएगा, it would be R into T. Remember, R and R square would cancel each other, and we are left with equals to V square divided by R into T. This is the third equation for electrical energy. So basically ये सेम चीज़ें हैं, but हमने थोड़ा सा रीअरेंज करके लिखा according to the requirement of the numerical problem, right? आपको जिस भी टाइप का numerical problem एग्जाम में गिवन होगा, आप उसी टाइप का यूज़ करेंगे. सपोज अगर आपको just simply I and V given है, then you are going to use this equation. अगर आपको एग्जाम में I के साथ V नहीं R given है, then you are going to use this equation. But अगर आपको I ही given नहीं है, V given है directly, So then you will have to use this equation. So it just all solely depends upon the requirement of the question, right? So this was the topic, electrical energy. Coming to the Joule's law, it says that it's just a simple law. हम इसे thoroughly discuss नहीं करेंगे 10th class में. We are just going to study the definition of this law and the basic principle. What does it law say? So by definition, the amount of heat given off by the resistor is directly proportional to the product of square of the current, resistance, and the time for which the current passes through the resistor, right? So the amount of heat given off by a resistor, okay, so H is the heat given off by the resistor. Heat or heat lost by the resistor, okay, of course जब भी हम किसी resistor को potential difference apply करते हैं, then that resistor would heat up, and that heat, हम उस heat को evaluate करने के लिए Joule's law use करते हैं, and it says that this heat given off by the resistor is directly proportional to the product of square of the current, the resistance, and the time for which the current passes through the resistors. Okay, so यहाँ पर heat which is emitted by the resistor would be equal to, इन तीनों factor पर depend करती है. It depends upon the current, it depends upon the resistor, and it depends upon the time for which the current passes through the resistor. जितना ज़्यादा current होगा उतनी ज़्यादा heat given off होगी, जितना ज़्यादा रेजिस्टेंस होगी उतनी ज़्यादा हीट प्रोड्यूस होगी, जितनी ज़्यादा टाइम के लिए करंट पास होगा उतना ज़्यादा हीट प्रोड्यूस होगी, राइट? सो वी आर गोइंग टू जस्ट कन्वर्ट दिस प्रोपोर्शनैलिटी साइन इनटू इक्वालिटी साइन. So proportionality को equality में change किया तो definitely we have to introduce some kind of constant over here. So this constant is called, this is called 1 by j. Okay, this is not just j. This constant is equal to 1 by j, and this j is called the mechanical equivalent of heat. Okay, so the heat given off is actually the product of all these parameters divided by the heat given off, as mechanical energy. Okay, so इस पूरे आपके mechanical process में जितनी energy use होगी, we have to divide that energy divided by the current, the resistor, and the time. Then the remaining energy would be the heat given off by the resistor. Okay, these two are different terms. This is the mechanical energy, this is the mechanical work that is actually done by these three parameters. And जब हम इन दोनों को डिवाइड करेंगे, then जो remaining energy रह जाएगी, that is called the heat energy. This is dissipated in the form of heat from the resistor. That is why जब भी हम किसी electrical component को किसी भी circuit में connect करते हैं, then we actually observe that it gets heated up in some amount of time. So this is how we can calculate the heat dissipated by any kind of resistor, and it depends upon the current, the resistance, and the time for which it passes through the resistor. Thank you so much, everyone.